Okay, so this is the outline for this very brief conceptual introduction. First, I'm going to talk about two approaches to data visualization APIs. I call them Tell Me How and Tell Me What. I'm going to talk a bit of the Wilkinson grammar of graphics idea, then about Altair, Vega-Lite, and Vega, and Altair in practice. Okay, so the first approach that I like to call Tell Me How is an imperative approach to data visualization, and this is what, for example, libraries as Matplotlib use. In this case, you are literally telling, giving very precise instructions about what you want to put on your screen, right? And the good thing about this is you have very fine-grained control over chart specifications. The cons are very verbose and make you think a lot about low-level details of your chart. On the other hand, what I like to call the Tell Me What approach, or declarative approach, is an API approach where you tell your program to do what you want to plot, right? And this is the case of Altair and Plot9. Plot9 is just a reimplementation of ggplot2 in Python. And the process that allows for fast development, conciseness, and more importantly, it lets you concentrate on the visualization content rather than in low-level graphical details of the chart. The cons is that you have less control over chart details, of course, but that doesn't mean that you cannot alter them. You can, but there's a ton of decisions that have been made by the people that designed the package for you, right? So you don't have to think about them, but probably you have to. You may need to carry on with them, or maybe you may need to look at the documentation and to start to change things. And the idea of declarative visualization APIs is based on the idea of grammar or graphics of Wilkinson. I don't know if you ever hear about this, but the idea behind this is to create a mathematical foundation for statistical graphics instead of using taxonomies of graphics. And the way in which Wilkinson tried to accomplish this is by proposing or creating a grammar to formalize this idea. And in this context, a grammar of graphic means a system of rules and primitives to generate meaningful, perceivable graphics, right? As a grammatical language, right, where you have primitives and rules to generate language, in graphics is just the same idea. And the main, one of the main motivations of Wilkinson for doing this is that taxonomies of charts are harmful. This is going to become more clear why Wilkinson proposed that these kind of approaches are harmful in terms of data visualization. So I'm going to talk more about that later. So why a grammar instead of a taxonomy? Taxonomy of charts are like lists of words, right? If you look at the documentation of many data visualization libraries, they have lists of types of charts, bar charts, line charts, etc., scatter plots, right? And the thing with that is that that limits the space of potential visualizations that you can create to that list. In the same manner that in language, the set of potential phrases that you can generate is limited by the vocabulary, right, of the language. On the other hand, if you use a grammar which specifies primitives and rules to combine those primitives, you can go well beyond those taxonomies. So the nice thing about grammars is that there is a generativity, right? But that doesn't mean that these grammars are limitless. There are limits, of course, on the kind of things that you can create. But the point is that you can create a lot more things that you can create just with having a taxonomy of charts. Okay, so what are the core elements of this grammar, according to Wilkinson? first you have your data, right? Usually tabular data. And then you have transformations, things like binding or ranking, etc. Then you have scale transformations that doesn't change the nature of the variable, it just scale them. Then you have coordinate systems like Cartesians and polar and other ones. And then you have the elements of the chart, like points or bars, and their aesthetic attributes like color. And then you have guides that are kind of like decorators around a chart. And the idea here is that these components link the data objects and specify any scene containing those objects. So Altair, Vega-Lite, and Vega are an implementation of this idea, right? So what is Altair? It's a declarative statistical visualization library for Python based on Vega-Lite and Vega, and was created by Jake van der Plas and Brian Greiner. As I mentioned, Altair is built on top of Vega-Lite, and Vega-Lite is a high-level grammar of interactive graphics for Vega. Vega-Lite is JavaScript, basically. So the idea was essentially let's port Vega-Lite to Python. And Vega-Lite, on the other hand, was like, okay, there's Vega, which is a very powerful visualization grammar for generating graphics. But it was really verbose and hard to use, so they built Vega-Lite on top of that. And very schematically, this is how Altair works. The first step for Altair is the Altair API generates a JSON Vega-Lite specification. That's what it does, okay? And then it takes that Vega-Lite JSON specification and is compiled to a full Vega specification. And then the Vega specification is parsed and executed using a reactive runtime, basically D3, yes. And finally, the chart is rendered in some user interface like JupyterLab or VS Code, and there are others, but JupyterLab is the recommended one for Altair. So these are essentially, every time that you make a plot or a chart here, those are the 4 steps. Now, as I mentioned, Altair and Vega-Lite are an implementation of this idea of the grammar of graphics. The way in which it's implemented in the specific case of Altair is by first taking your data, right? Usually a relational table. Then you make transformations to the data, like filtering, aggregations, bindings. Then you decide what is the mark, or literally the geometric object, to visually encode your data in the chart. Then you encode that to axis, X, Y, Z, etc. And then you can apply scales. And finally, you decorate around with guides to read the chart. One important note before going to a tutorial is that my talk is based on this tree. The Wilkinson book is really good. It's very dense. I just read a few chapters to prepare this, but I highly recommend it. There's a very brief paper of the Altair team about Altair. And the one that's really helpful to understand the inner workings of Altair is this Vega-Lite, which is like, why? Well, Altair is basically a wrapper of Vega-Lite. So if you read that paper, it's going to be very clear how it works. There's a few tutorials that I will recommend. The first one is by the creators of Vega-Lite. It's really good. This is one for Jake van der Plas. It's really long. It's like 4 hours of Altair. And there's a Leland Wilkinson talk about the grammar of graphics. I'm going to pause now. So questions about this first part before moving to a tutorial.
How much of Vega-Lite does Altair use? How much of Vega does Vega-Lite use?
Can you say it louder?
How much of Vega-Lite does Altair implement? How much of Vega does Vega-Lite implement?
So everything is Vega under the hood.
Right. But how much of the two wrappers implements?
How much of the wrappers what?
How much do the two wrappers implement?
Altair?
Yeah. How much of Vega does Altair cover, I guess?
So what do you lose?
Yeah.
As you go on from one to the other?
I'm not sure. I would say that the use cases for which Altair is designed, which is mostly descriptive and exploratory data analysis, are very well covered. And I don't think that you lose that much. I think that Vega is mostly about interactive visualizations. Interactivity is really, really powerful in Vega. And Altair also allows for interactivity. It's really simple to implement. It's very flexible. So I don't think that you lose that much in Altair. It's very powerful, in my opinion. Okay, so now I'm going to move to a tutorial. You got two options. If you want to follow along, you have two options. One is just clicking in this binder icon, and you are going to get an interactive online environment to code along if you want to. The other one is doing things locally, and there are the instructions. So I highly recommend just clicking in the binder icon. It may take like 2 or 3 minutes to build, so if you want to use it, just click it now. Okay. There are two notebooks here. One says talk, the other one is tutorial. I'm going to use the tutorial one, and the talk basically has all the code in it. And my idea is just to reproduce the talk one. So here are the contents that you mentioned. So I just got this data set from like some machine learning repository. It's not super important to pay attention to the actual data analysis. I'm just gonna focus my attention on the package itself. But if you're following along, just run those cells. The first point that I want to make that is really important is working with large data sets on Altair. I tried Altair a long time ago. It was like 2 point something. And I stopped using it because I couldn't plot things with large data sets. At the first time, I was like, oh my God, this is too buggy. I cannot use this. Then I learned why was that and how to get around that. So I just want to really explain how to work with large data set if you need to. So the thing with Altair is that it incorporates both the code and the data itself. Okay? If you try to generate multiple charts from a large data set, you're going to get a huge, enormous Jupyter notebook if you use that. Because for each chart, all the data is going to be within the notebook. Okay? It's going to be more clear. I'm going to give an example just to explain what I mean by that. So to prevent this, there's an exception that's triggered when you try to create charts with over 5,000 rows, I think. And there's a couple of ways to get around that. One is pasting the data by URL. Okay. The second one is disabling the exception. This is not recommended because you may get this gigantic Jupyter notebook that may render very, very slowly, and it's just a pain to work with. Your computer may crash, etc. The other one is just to allow your local file system to dump the data, and then it's going to be linked to your chart. It's going to read it from there. So the data is not going to be inside the notebook itself. It's going to be outside. It's going to be read from there. And the final one, that wasn't recommended to me by Jake, because I asked in GitHub about this issue, and Jake Vanderplat recommends using this Log data saver. I'm not going to go into that, but if you want to learn how to use that, it is recommended by him. You can click in here. I'll learn more. So for now, what I'm going to do is just to allow my local file system to cache out the data and then read from there. Okay, so the data that I have here have over 100,000 rows. So if I try to run it, you're gonna get this error, max row error, doesn't work. Okay, so you can use either JSON or CSV, and the way to enable that feature is just by this: all data transformers that enable CSV. If I enable that, and now I'm trying to plot, may take a few seconds, and there it is. Okay, that's the chart. Now, it's a very humble small chart. It took like 4 seconds to render. Okay, and this is the reason. So one cool feature of a chart that you can save just by clicking here. What? I cannot see the thing. Well, anyways, I'm just gonna show you this later. So it's too small. Is that okay? Okay. So here what I'm doing, just grabbing the chart object and generating a dictionary from it. And this is all the information that is inside the chart. So, and this is the key thing. If you see here, this is a URL, and that thing is in here. So if you double click this, all this information normally will be saved along with the code that generates the chart. Okay. In this case, it's cache out outside and in my local system, so it's linking the thing now. So now it can render the thing. Anyways, I'm just gonna delete that for now. So that's one way to work with very large data sets if you want to do visualizations with large data sets. If that's a problem, you may look at the data server thing that, according to Jake, is better. But that is one way. For the purposes of this talk, I'm just gonna take a sample of my data, and I highly recommend doing that. I mean, if you have a very, very large data set and you need plots, you may take just a random sample, develop all your code, and at the end you just change the data set and just run the thing once. And that's gonna be really fast. Okay, so I'm just taking a random sample. This is not super important. I'm just gonna move here. So, the more basic chart that you can do with Altair is a single Cartesian chart. Okay, this is also referred as a single view. View is a concept that the authors like to use, and basically describe a graphical object composed of a data set, a mark type, and a set of encodings, such as for visual channels such as color, size, position, etc. Okay, so I'm going to give you the first more basic example of how this works. So to make this work, we just need to follow the same workflow over and over again. So the first thing is pass your data. If you remember, the first Berlin block was the data. So I'm just gonna pass the data. And the second step was to decide what is going to be the geometrical object that's going to represent the data, right? So in this case, you're just gonna pick ticks. Okay, and the first step is to decide on the encodings. What you want to encode in the object, right? So, for instance, here I'm just going to pick number of medications, and there you go. Okay, so this is very, very basic, but more complex plots are going to follow the exact same 3 steps all the time. And if you notice, instead of like thinking on, oh, what kind of plot I want a straight plot. I'm just going to call like straight plot parentheses parameters, right? This is different. You're generating the straight plot on the basis of data, a geometrical object, and encodings. That's the philosophy. Now, there's a lot of ambiguity in this specification. It's underspecified. There are a bunch of details that are not specified here. I don't tell where to put legends, the scales, or colors, or nothing, right? And the idea here is that Altair is going to pick sensible defaults for you. And this wasn't done like haphazardly. It's what very carefully thought by the people that designed Altair to follow good practices on data visualization and in statistical graphics. So you can trust them, but you can change it if you want to. So let's generate a histogram. Again, as I said, you don't call the histogram function here. You generate the histogram. So again, to generate the histogram, as you're gonna paste the data. Now I'm gonna pick a geometrical object to generate the histogram. Does anyone have any idea what kind of geometrical object should be used in this case if I want to generate a histogram? A bar, right? A bar, right? So it's a bar. And the encodings that I'm going to use, this is a different way of passing the same parameters, alt.x. It allows you to add extra things other than just the data. Okay, so I'm going to pass x there. And this one important thing is not just like if you want an histogram, you need to do some transformation in the process, and that transformation is binning. Okay, so here, oh, sorry. Whoop. Here, you just tell tar, I want things to be bin. Okay, and after binning, there's one step that I'm missing because now, so far, I've just encoded the x-axis, right? I just tell Altair, okay, the x-axis I want number of medications, okay? But what kind of aggregation is being done to generate a histogram? Does anyone has any idea?
You determine the width of each bit, right?
What?
You determine the size of each bit.
You don't need to do that. I mean, you can, but the aggregation that is done in the y-axis is count, or you're counting. That's what you're doing, right? So here I just tell tar, okay, and count this, right? It wasn't the screen. I just realized. But I have a typo somewhere. Chart. Oh, yeah. And there you go, right? If I set this to false, you get that, right? Is that different? I mean, it's binning anyways because of the nature of the data. But if you want a nice looking histogram, you can bin there. I'm gonna ask you to hold on a bit real quick. I just need to. I'm gonna pass like in 5 minutes. Okay. So one nice thing about Altair is that it's pretty easy then to customize and build on top of things to make plots more complex, right? For instance, if I want to segment this data by race or ethnicity, it's as simple as changing one encoding, right? Now I have to add one encoding that's going to represent race in this case, or ethnicity. And here I can grab the last object that I created and just change, or in this case, add one more encoding. Whoops. What I did wrong. Oh, thanks. And there you go. Okay. And if you notice, you don't need to add these lay-ins over here. They were automatically add. The colors were automatically picked. You can change all that if you want to, but it just allows you to write code really fast if you want to explore data. Now, there's another thing that's interesting, that there's another default. The bars are stacked. I didn't ask Altair to stack the bars. Just did it because it just sounds like the sensible thing to do if you want to be able to tell apart things. Otherwise, the bars will be plotted on top of each other. You wouldn't be able to see the thing. For instance, if I do this, whoops. Oh, okay. Here's one mark bar. I'm just gonna add some opacity. Code. I can't. Okay, I'm gonna explicitly ask Altair to not stack things, right? This is what happens. Everything gets plotted on top of each other, right? So you need to have to specify that. I'm not sure if matplotlib does these kind of things, or probably you have to tell matplotlib, oh, go and stack the things, because otherwise I won't be able to see it. And if you notice, there's another smart thing that's done here, is plotting things, is plotting bars on top of each other. It's just picking the larger one on the back and then the second one, so you can see them all. If you plot the larger one on top, you're gonna see anything. Okay. So let's look at another very common plot, and scatter plot. Again, it's as simple as you follow the same workflow. Now, what geometrical object should encode data here for a scatter plot? It's not a bar. It's not a tick. A what?
Cross or something?
It may be a cross or a dot, right? So now I just say, now I want to represent things that dots, or in this case I'm going to say circle. It's the same thing. And now I'm just going to add some encodings, right? And there you have, right? Scatter plot. Again, you don't call the scatter plot function, you generate scatter plot. What about a heat map? Right? Just gonna drill this over and over again. That simple. What kind of geometrical object represent a heat map? Like a grid? Yeah, and a grid is composed of what? Square, rectangles, right? Whoops. Rectangle. Encode these things, right? I want an H, race, and just gonna add color to make things more colorful. And one thing that's interesting here is that Altair, again, it chose a sensible color palette, right? And it also matters what kind of variable are you using. Heat maps are going to look different if you're using a nominal, a quantitative, or ordinal variable. Well, I think I have an example about that here. But there's another thing that is nice about Altair. Is it's going to pick a nice way to represent everything based on your data type too. Now I'm going to pause again. Is there any questions?
There's somebody reporting an error.
An error?
Yeah.
I think that we can look that up later. I'm sorry about errors. Is everyone getting errors?
No, that's just my particular setup. It's working fine on the binder.
Yeah.
But when I tried to install everything on my particular Python, which you're not responsible for,
Okay.
I
Okay.
got like a front end error. So I thought I just do it for later reference.
Okay. Thanks.
Don't get distracted.
I had a question about bins.
Okay.
So yes, there was bins, true and false. But what if I wanted 10 bins or 20 bins? Could I do that?
Yeah. Yeah, it's very simple. I can't remember from the top of my head. But it's just like probably comma something 10. It's very simple. Yeah. That's a good example of. So Altair is picking everything for you, or almost everything, right? But of course, it allows you to change all those defaults. And that is what it gets imperative instead of declarative. But it is declarative because in principle, you don't need to, right? So that's the whole point of the thing. Now, as I mentioned, if you want to customize things, it's really simple. In this case, I can grab the previous heat map that I created, and I can just change one encoding. In this case, I'm going to change the color to. It's better if I just copy paste this to this. And what I'm doing here, I'm just telling this thing, okay, I don't like this color scale. I'm just going to use this one. Whoops. Heat map. No. What I'm doing wrong? I miss what?
You're missing one more parent. You close all red, you close color, you didn't close the color.
That is in code.
And it's heat map.
Ah, thank you. Yeah, there it is. So this is pretty small. So if you want to change the width and the height, is as simple as doing. Okay, I'm just going to change the properties now. Right, these are the properties. Right, in the properties, I'm going to have the width equal to dimensions. That's 300, and the height going to be equal to dim times this 40%. Okay. If you do that, and you change the dimensions, okay. There are multiple ways of changing these kind of things. You can this kind of a local change in the configuration of the chart. You can do it globally here, but again, it's not recommended doing that unless you want to create some sort of template that share some dimensions or color palettes or things like that, because it's going to apply to everything. You can use it as a base, but you can change it. But if you're changing things for just one chart, it's considered a good practice just to do this. So as I mentioned, since Altair is wrapping Vega-Lite and Vega-Lite is wrapping Vega, there's a lot of things that are not necessarily in the Altair documentation. They are in the Vega-Lite or the Vega documentation. For instance, if you want to look at different color schemes, you can go here. This is the Vega documentation, and here you can watch and pick a color scheme that serves you better. Vega is really extensive and complete, so Altair really benefits of all the things that are built in these other libraries. Okay, so that's just one chart or a single view or a single Cartesian specification. Now we have multiple unit specifications, right? Or multiple Cartesian charts or composite views. The reason why I repeat over and over again all these ideas is because there is a conceptual model here. I'm trying to do the best that I can on communicating the idea that there is a conceptual model that follows. There are single views, composite views. Everything is part of the grammar. Okay, so there are 4 fundamental operations to compose a chart in Altair. There are just 4. There is faceting, repeating, layering, and concatenating. Okay, if you want to create multiple charts, you use one of those operators, and they're literally used as operators. You use plus, and etc. Okay, so here I'm just gonna give you an example of faceting. The first thing I'm gonna do is just create a base. Okay, so the base is gonna be same thing. Gonna be a bar. I'm gonna encode here all the things. Okay, that's good. I'm just gonna change the properties. Width, say 200, and height 200. Okay, so that's gonna be my base for the faceting. Okay, so this is very similar to what I did before with the histogram, and this is how you facet things. It's very simple. You take your base, okay, what you just did. You call facet. Here I add in this column variable, and there you go. Now it's faceted. So it's basically decomposing the data into 4 charts based on the race variable here. Okay, so as columns. That's why you call columns. Column, column, column. Okay, and that's all that it is for faceting. It's very simple. You just pick a column and you say, now I'm going to facet this. Now layering. So layering is just plotting things on top of each other. It's very simple. It is accomplished in 2 steps. We first generate each plot independently, and then we add them together. Okay. So let's take this bar chart. Bar encode these things. Okay, step 1, first chart. Now let's say that I want to add a line indicating the average, the overall average of these groups, right? That is an object that is called a rule in Altair. Okay, so to create a rule, what object is that? The object rule is just rule. I'm just gonna change the color here to red. I'm gonna encode these things. And the encoding of the rule, what I want the rule to represent is the mean in that variable, right? So if I call that, I'll literally just get a chart of a rule. And this is the cool part. How do you think that I can layer those 2 plots together? You literally add them. mathematically add them. So this is bar, add bar with rule. Gosh. And there you have it, right? What I really like about this is that I don't need to remember. I just have a hard time remembering Matplotlib and other libraries. By the way, I don't want to sound like I'm just criticizing Matplotlib. I really love Matplotlib as it is really a really powerful, flexible, well-tested library. Is amazing for many things. But it just puts so much cognitive overhead for me. I can never remember how to do something, never. But if you learn those primitives and these combinatorial rules, it's a lot easier for me just to remember how to generate something. I may look up the documentation once in a while, but the important part is that you're learning a mental model, right? So the third one is concatenation. And this is pretty obvious. And actually, when I discovered I could concatenate things like this, I was blown away. I'm like, oh my god, I struggle so much concatenating things, charts, in an arbitrary manner in other libraries. And here, just so simple. Okay, so let's play another var. Encode these things. Okay, so I got bar 2 now. And concatenating things horizontally is as simple as calling bar 1. Gosh, I can't remember the name of this symbol. Help me out.
Or.
What?
Or.
Whore?
Pipe.
Pipe? I call it stick. You use a stick symbol and everything fails. Wait. There you go. They are side by side. Now, to concatenate things vertically, I got this chart here. Bar. By the way, looks like Jupyter Lab is getting better tab completion stuff. It used to be very slow and bad. Now it's working very well, surprisingly. Encode these things. I'm just creating a new bar because it makes more sense to concatenate this one vertically. Okay. So to concatenate things vertically, you use the, what's the name of this one? I just call this funny and ampersand. Okay. You use the ampersand. You can concatenate bar 2 with bar 3, and there you have it. Okay. And then I think that I'm going to show an example of this later. You can concatenate things arbitrarily, right? If I want to add bar, if I want to do this, it's going to work, and so and so. It's very simple. Now, repeated charts this is more like basically the people that created these libraries saw that there was a very common use case for concatenation, and they just created this repeat operator to make that process easier. So the idea here is to create multiple plots based on a list of encodings or column values, and this is how it works. So again, I got my chart. What is this chart? So bar 2, and I encode these things as usual. Okay, and now this is what I need to add. I just call the repeat operator and add the rows and columns that I want to repeat and repeat. And there you have it. It's basically concatenating in a smart way. And if you look at this closer, you're going to see that in the left column we have this one. The left.
What is the definition of concatenation?
The definition of concatenation?
Yeah, it's a new word for me.
I call that gluing things together.
Oh, sort of like cloning.
Yeah. No, it's not cloning. You have two things and you glue them together, sticking together. So if you look at this carefully, you're going to notice that in the left side of the chart, this column is the number of diagnoses. In the right one, we have the numbers of medications. And then in the top row, we have race, and in the bottom row, we have gender. So you can compose charts pretty easily just by using these this operator. Okay? I'm just going to keep this one. What time is it? Okay. I have 20 minutes. I'm good with time. Yeah. So, one cool thing about Altair is that you can add interactivity just by calling one argument, which I think is pretty awesome. If you think on another implementation of the grammar of graphics idea with ggplot2 in R, ggplot2 is amazing, but it doesn't allow for interactivity, right? You have to use other tools for that. But in Altair, you have both things. And for instance, in the case of the scatter plot that I created before, the only thing I have to do, now it's failing, interactive, is to say, now make it interactive. And there you have it, it's interactive now. So this is very bare bones interactivity. You just basically can pan and zoom. So you can zoom like this and move around the dots. But it's progress, right? You just have to call interactive. Now, to make things more interesting, you can add something called selections. So this is the way in which you use them. In the properties of the scatter object, you said use a selection, this interval thing that I created here. This integral, I can just pass this in here, but, and what this does now, it does allow you to select some area in the chart. As in now, this is not very useful, but it's going to become more useful. Now we can add encodings to the selection. For instance, I can tell to this, he's going to copy, okay, interval. Okay, here in the interval, I just said I want to encode this. Just give me the y. And if I try to use the selection now, it's just selecting over the y-axis. If I change this to the x, it's gonna select over the x-axis. Okay. Now, what is really cool in here is that you can add selections, you can make selections conditional. Okay, for instance, we can make the color encoding conditional by modifying the color property. This is what I mean by it. So in the color, just gonna call this condition interval. Oops. Should work. Okay. Now I can do this, right? Now the selection is conditional. Just coloring the things that I selected. That's what it's doing. And you can also this is concatenation. You can also concatenate interactive plots in the same manner that you can concatenate static plots. And this is very cool. If you do this, what I did wrong. Okay. Yeah. All right. So this is a cool part. If you look at it, in the left we have this scatter plot, and in the right what I did was just to change the Y encoding. Right now in the Y-axis is encoding a number of diagnoses. So we have two different plots. And now you can look at the relationship between plots using the conditional selection that we added before, right? So if you're curious about, oh, I just want to look how these outliers are around here, look, they're around here, right? So, and I think that why this is very important is because it allows you to discover relationships in the data that otherwise will be really hard to find, right? So it's giving a higher purpose to data visualization here, right? There's not visualization to summarize or to show something that is in numbers. You're also discovering relationships just by creating charts. And the interactive part of it is crucial here. There's no other manner in which I can find this out if I don't add interactivity, right? Now, composite charts, and this is the thing of why the grammar part of it is so important and why it's so powerful, is because you can just keep doing it. You can keep, for example, concatenating or faceting charts on top of each other, right? Using the same composition operators. So here, for instance, I can call this one scatter dash or dashboard, combine it with the facet one that it did, and now you have a dashboard of charts, right? And the interactivity is preserved. And this is really powerful because then you can continue combining things, and you can compose dashboard in whatever arbitrary way you want just by using the same operators again. So for instance, here you're gonna use this one, be concat and is want, and I have a different one, right? And finally, you can go really crazy and just do meta charts, right? If you have a meta chart here, you can combine it with a meta chart here, right? So here, the only thing I need to do is just to call the first meta chart that I did with the second, what was the name of the second one? Meta chart 1. Oops. One. There you go. See? You can keep repeating this operation over and over again. It's gonna get like really weird, but whoa. What I did wrong? Another chart. Anyways, you get the idea. So this is Altair. There's a lot more to Altair, like a lot. It's really powerful. It's really flexible. The documentation is really good. Those tutorials that I mentioned and the papers and the book are really good as well. There's also a lot about the interactivity part that I didn't mention. It's kind of dense. There's also a grammar of interactivity, right? All the grammar, all the fundamentals that I mentioned before about the grammar are the basic building blocks that allow to build everything else. There's another additional grammar which is all about the interactivity part of it. And the paper about Vega-Lite is really good about that. It's more dense, so I didn't want to go over that for time considerations. But there's a lot of things that you can do in terms of interactivity. The only things that I never tried here are animations. I don't know if Altair support animations and 3D charts. I don't recommend you using 3D charts anyway. Perceptually are bad for humans. So, but the nice thing is that Altair is being actively developed. Every time that I ask a question or I put an issue in GitHub, I get a response like in 30 seconds. They're really fast. And Jake is the one answering everything, like automatically. So it's really cool. And that's all I got. Any more questions? There's any question on Slack channel? Nope.
I have a question about setting.
Sorry, I think that you were first, then you, then you. Yep.
Yeah, I'm curious. I noticed the histogram thing. It had this like automatic set bin width. Does it also generate kernel density plots? Does it able to generate like lines of regression between
Yeah.
x's and y's? And, like,
Yeah. If you look at the
where you have like one dependent variable, one dependent variable, multiple independent variables, and it can like show the actual versus the predicted on the dependent variable, that kind of stuff.
So I can't do it now, but I'm sure there is a way. Because as I said, this is very flexible. There's a ton of examples. And since this is a grammar, right, in theory, you should be able to use the primitives and the combinatorial rules to generate that. I don't know how at this point, but
overlay one diagram on top of the other, right? Manipulate your data to get a regression line, manipulate your data to get some other thing, put them on top of each other.
Right. You still need to have the libraries to create the lines of regression and
To manipulate the data. Yeah, instead
Right.
of just projection and selection, you have to have operations.
right.
yeah, one thing I forgot to mention is that Altair is fully integrated with Pandas. It works on top of Pandas. I like that. Sometimes I go back and forth between NumPy arrays and Pandas data frames to make plots, and that things get messy and complicated. Altair is built on top of Pandas, period. And I think, at least in my use case, make things a lot easier because I just find easier to manipulate data in Pandas. But yeah, your question.
Yeah, this is really great. So I was really impressed by the interactive plots, and as a heavy Jupyter Lab user myself, I could see this being really fun to play with. But I have coworkers and non-technical stakeholders that I work with that I want to be able to show this to them, and I want them to have that fun. I want them to be able to like click and drag and that sort of thing. but there's no way they're going to install JupyterLab.
Really?
And so that's that's their loss on some level. But is there some way that actually I can work with them with this? Is there a way to export this or
Without-
keep
without-
in mind, I don't know any JavaScript, so
Okay.
I'm helpless on that front.
So you want the interactivity part without JupyterLab? That's your question?
Yeah. Is that?
I mean, I haven't tried. I know that, for instance, if you go here in the web page, and I'm pretty sure that this is Python. I don't know how. I remember in one of Jake's talk mentioning something about that. I can't remember exactly how it's done. I know that it worked with VS Code. That's one thing that you can use if that is an option for you. It works well with VS Code. And I know that there must be ways to embed the interactive plots somehow, but I don't know exactly how. So wait, I have there was another.
So I have an answer to this question.
Oh, okay, go ahead.
So they're on a static web page, right? So that web page on Altair is like another, that's just HTML, that's all it is. So there must be a way to get the Altair plots in HTML, right?
Sure.
And then you can send that HTML file off the.
If there's some sort of export to HTML.
Yeah, there is.
Take care of it,
You can
yeah,
actually
that's
export to
no problem.
HTML.
There is.
Yeah.
It's in the JavaScript in the library.
Yeah.
Okay, can do that too.
As long as the JavaScript is a blob that I can push, then I'm okay.
Yeah.
But as soon as I have to like start coding.
Because it embeds all the
Vega is just pure Java.
Yeah, actually, I think that if you go here and you open this in the Vega editor, come on, run. Oh my God, doesn't work. Anyways, but I was expecting to. Anyways, with your question, didn't work.
I have the same motivation.
Okay.
We don't care so much about interactivity, but for those of us who are old men who prefer VI to like working in Jupyter Notebooks, I do work in Jupyter Notebooks, but I'd much rather just work in code. Can you talk briefly to the export capabilities if you're going to do it, like not, through the interactive save, like what? Kind
Not
of,
here.
No, if you're going to like export to files, PNGs, to GIFs from the command line.
Yeah, there is a save, saving Altair charts here.
Oh, perfect. Okay. I'll
Yeah,
do that.
this is a chart save. You can save to PNG, SVG, and I think that I'm not quite sure at this point, but I think that there was this is HTML.
Sure. Okay.
Yeah, and there's like a lot of
Perfect.
options there for saving. It's pretty easy too.
So one use case I want a lot is to have a slider and then have a plot.
Widgets.
Yeah, widgets.
Yeah, there are. I think that Altair widgets. There you have it.
Okay, all right.
It got everything. You can bid it.
Yeah. So I laugh because I developed this library, and I don't want that.
You don't want that?
Yeah.
Yeah. Any other question?
So I want a widget that I can embed on a static HTML page all by itself. And this requires some Python backends.
Okay, and
Yeah, right.
cool.
I was wondering if it's been a while since I looked at Altair, like a long time, and I didn't know if there was anything new in the interactivity.
There are things. There are version 4 of Altair was released like a month ago, and along with version 4, there are 2 extensions to Altair that do a lot of things that I can't remember. I think it's this transform, viewer, saver. These 3 things were added. Transform things. The viewer, I think, is really powerful because it allows you to, what it does, can't remember.
That looks like what I want.
There's a saver where you can save everything in JSON, HTML, PDF, everything. What I really like is it's been so actively developed. So new cool things are at all the time. If there's anything that it doesn't have or it can do that you want it to do, you just can go to GitHub and say, oh, it will be cool if you add this. And I'm almost sure it's going to be added eventually. Because I think that Jake is pushing very hard for, like, let's use declarative visualization. It's amazing. I agree, it's amazing. I basically changed all my plots to Altair. And one, they're all easier to do, and two, they all look better. They look really nice. I mean, it is just like, I just find these aesthetically pleasant to watch. Because the people who complain, oh yeah, Python charts look awful, ggplot is amazing, and blah, blah, blah. I like this better, actually. How nice is this? Look at it. It's really nice. Okay, any other question?
Sorry, I just want to go back. You said there was something built on Panda.
Pandas, yeah, there's a library to wrangle data, tabular data in Python. Yeah. So, Panda's like an animal panda. Yeah. I think it stands for panel. I think it was originally created to analyze panel data. That's what it's called, Pandas. Anyways. Yeah, I remember an interview of the creator of Pandas. It was like he was working in like with panel data, and he developed this library. It was panel something. Yeah, fun fact. Any other question? Nope. Okay. Thank you so much. I'm gonna stop the recording now. I guess now we have to